Hello, welcome to AG Engineering again. Job for today, I've got a BSA A7 set of crankcases and a crank that's got to have the bush fitted in the crank. They've got a bush one side and a bearing the other side. Commonly quite, at this point, quite worn and need a replacement. Very common fault on these. The bush is also the crank feed for the con rods, so the clearance is quite close to make sure that oil pressure stays up there. The old bush has already been taken out of the cases, you can see in there, and there's our new one to go in. I believe the originals were a steel bush with a bronze insert. The ones that are done now are solid bronze, solid phosphor bronze, so there's no risk of the steel insert, the bronze turning in the steel insert, which I believe happened years ago. I've had a measure up already on the inside diameter of there and the OD of there. And we've got, I'm getting 2,7/10 sort of upper limit to 2,4/10 at the sort of lower end. So we need to drop this bush in and not press it in, because otherwise it drags metal up. So I'm going to get this in the freezer. Wrap it up and leave it in the freezer for a while, and I'll set up to warm the cases up with whether it's with a blow lamp, a flame one type thing, or next to a heater, we'll see. And then I'll come back and get the bush in place. I've also had a little trial with the crankcases in the milling machine. When they're set up flat on that surface, I've took all the studs out for the oil pump and that. It just leaves the two locating studs for the timing cover there. They'll set up flat in the mill. Just bring the camera over. Yep. Now that'll set up flat in there quite nicely, and setting a square against the bolted together cases, and also running a gauge, dial gauge up and down this. It's within sort of half a thou of vertical, and I've had a DTI in there and centralised it, and had the other half of the case on there, and also centralised that, and again we're well within our tolerance. So you go off that surface there, off that bearing surface, take the table up and measure the inside bearing surface, and you want to be vertical and concentric on them two bores, so that you know once you've got that, both these centred, that bore and that bore are in line with each other, and everything's vertical, and you've not got any discrepancies in sort of off axis of the crankshaft, if you like. And then it's a case, once the bush is in, of boring it to the crank size. Now, if I turn you round again, on the crank here, there's our timing side journal. I can't get that in, drop the crank in and put the other case on and keep trying it in that way, because I simply haven't got enough room or height in the mill. So what I've done previously, I've measured this up and I've made up a test plug to that diameter, so that as I'm boring, I'm going to take a little bit out and check with the test plug until I reach the dimension. And I believe the clearance is something it's like 1,000 to 1,500 clearance on that journal. So it's got to be quite a precise operation. So I'll be making a test plug for that as well. So I'll come back when I've got this bush cooled down and the case is warmed up, ready for installing the bush, and we'll get a bit of video of that. So see you in a little while. Right, I've got to warm our cases up here for the bush fitting. So I've got a combination of things going on. I've got a heat lamp just to warm the general area, and I've got the propane burner as well. So I'll get some heat into this. We'll get it up to around about the 150 degree mark, something like that, and check it with a thermometer, infrared thermometer. So one of these, we're on at the moment. So we're currently at about 13 degrees. Heat lamps 300-ish. So we'll get it warmed up and get ready to fit the bush. I'll put back when we're up to temperature and we're ready to fit. Been warming this for a good few minutes now, and the temperatures starting to come up nicely. About 150, 160. Keep going, soak some heat into it. Okay, I've got the bush in the freezer just beside me here. It's been in there a while. It's mounted on a mandrel, so I can hold it. Just get some gloves on. The case is sitting on some vermiculite board. It's not just on a piece of chipboard or anything. It is fire resistant. And I've got a couple of marks on the bush to line up for where I've got to be for fitting. So here we kind of go. That's it. No hitting at all. Just drop straight in. Sometimes they need a little bit of a tap, but there it is. Just falling in. No hammering, no banging, no pressing. So you know that you're not dragging any aluminium out of the case. Sometimes they need a little bit of a tap, but with a cold bush, a frozen bush and a hot case, that's worked beautiful. So I'll come back to you when this has cooled down a bit. It's already grabbed. There it is, sat in there. So it's already got it in the heat. It's starting to transfer up the bearing driver handle. It's been an hour or so since we did the cases, and we're back down to a normal temperature. We're in there, 25. So that's good to go, ready for setting up for machining the bush to diameter. This little threaded hole was in need of a little bit of cleaning up. It's for an anti-drain back valve, and there's a little ball bearing and a spring behind it. You can see them there. Now that's the original screw that's on them. It's only got a couple of threads that goes in. Obviously that's setting normally the tension of that spring. Now, of course, it was damaged. I had to tap it out a little bit deeper. So what we've done here is made a little cap with a recess in it, so it gives us the same depth as that, but the spring assembly can go into that little recess like that, and we've got sort of 4 times 4 pitches, so we've got twice the amount of thread engagement in there. And I've checked that the oil weighs clear at the back there. We're nowhere near that for with going in deeper with the thread and the cap. So they'll get reassembled when the engine's ready to assemble. But one of the things we do need to check is that we've got an oil passage from actually the other side, from the oil pump side through into the bearing. So before I go any further, so what I'll do, we'll get a little bit of spray oil. I'll hold my finger over that hole there and just spray a bit of oil into there, and we'll see that that's coming out through the bearing, so we know we've got passage for the oil. I did check before it went in that the groove lined up with the hole there, so I was happy it was going to work anyway. But just as a final check, you do need to do that. Make sure you're not blocking off the oil ways before it's too late. So I'll take this in and get this set up on the mill, and we'll proceed to the next stage. At the mill now, with our cases clamped down to the mill table, the head has been trammed in to be perfectly perpendicular to the table. Very important for this operation. And the 2 case halves are bolted firmly together. So what I'm going to do now, I'm going to set up a dial test indicator in the spindle, and I'm going to dial in on this bearing race just inside there. Let's move you up a little bit, move the camera up a bit. So that's where we're going to dial in and make sure that we're concentric with that one as a first stage. As a matter of curiosity, only very roughly, but we also check that we're perfectly square with the mill table that way, and I've had a dial indicator on here as well. I'm getting the same reading sort of in that position and that position, so I'm happy that that's correct as well. Okay, I've been setting up this with the dial test indicator there, so we're on 0 at that point. And we're on 0 at that point. And we're on, sorry for the angles, 0 at that point. And again. And around there, see that we're on 0 again. So we're dialed in to the top brace there. So now I'll drop the table down. At this point everything's locked up. The X, Y and Z axes are locked. I'll undo the Z, drop the table down, take the top case off here, and we'll set up and just clock the bush at the bottom, see where we are there. Right, again, apologies for the hand camera work. Okay, I've removed the top case, top half the case, and set up the dial test indicator again. Brought the table up. Again, everything's locked. Z axis down there is locked. The X and Y are still locked. So let's see what we've got. We've got, from seeing that, we've got 0. Yeah, just about 0 on there. Move it around. And we've got 0 on there. Get that in the shot. Just about. Yeah. And move it around again. And just a hair past 0 there. Yeah. And then round again. And in the mirror there, just at the back, if you can see that, no you can't, just about in the background there, and we're on 0 again there. So we know that we're concentric with the top bearing race, and we're centered accurately on the bush there. So the next stage is to set up the boring head and take the first skim. Just before that, actually, I'll just remeasure the bush and see what it's reading now. So again, back in a moment. Then 13419 there. 1342 there. One three four two. So we're looking sort of 1342 region we've got to start with. Okay, I'll set up the boring head and take the first light skim, see what it looks like. I'm set up here with the boring head now. I've set the tool holder, to a 0 to sort of slightly negative rake, because we're doing a brass based material here. So that's just by adjusting the angle that this boring bar's sitting in the boring head there. I've adjusted it over. It's got quite a bit of overhang here, but whichever position you end up with the boring tool in, if you come this way, your screw's starting to come out of the adjuster. If you put that into this hole, so it doesn't quite work out exactly. I have got another boring head, but it's an automatic one. It's a lot bigger, much more awkward to get into these confined places. So I've adjusted it out. I've had a little sweep round just as a second check that I'm as close to concentric with the spindle axis as I can be. So all that remains is to take a little light skim and see what we've got. I've measured what was I getting, 1341 ish. I've got to go to 13436 is my journal, and you want about 1 thou to 1 thou and a half clearance. So we'll aim for 1344, which is actually the journal size in the BSA service bulletin for this job, and we'll see where we go. Okay, first light skim. I'm just starting to contact. Looking at the cut there, right, it's just started. That's a fairly even cut all the way around. That's getting better the further it's going in. You can tell by the sound of the cutting. Little tiny bit intermittent just at the start, the first sort of 1/8 of an inch, and now it's Now it's looking nice and even all the way around. Just try and move in a little bit closer. Put all the way down there. Now that's showing up on the camera. That's took maybe half a thou out of it. At this point now I've got the first cut. I'll take a measurement once I've completed this one. So I've dropped the table down, put the gauge in. And we're at that 1.34175 we're at there. So 275. So I'll take another thousandth out. The adjustments just on the is one division on this boring head, so it's got half a thou travel, 1 thou of increase on the bore. We'll tap the speed up quite a bit. Okay, that's with another thou off. We're in the region of got 1343 straight. One, 3, 4, 4. So we're kind of close. So our test plug should this is really the gauge of how the crank fits. It's just starting to go in a little bit tight, just slightly. Remeasure. Okay, I'm on 13432 there on the gauge, and that's what I've sort of got on Oh, test piece there. Maybe 13433. So yeah, I'm close to that size, which is 4/10 smaller than the crank pin diameter. So I need about another thou for me running clearance. So I'll go again with just a spring cut without any changes to the setup. Right, I've removed the crankcase from the milling machine. That's round here. And for the bush boring. There's our test plug, which is a sliding fit with. It's undersized to the crank, so there's a bit of play in there. If we measure our crank again, so we're on our 13436 there. And get our gauge. Sorry for all the hand camera work. And we put our mic on incremental. You measure 2.5. Sorry, 1,002.5 there. So we're definitely within the range of where we want to be. And there we go. That's on, and I've got a little tiny bit of rock there. Now I'm not actually going to be putting this engine. Just get me in the shot. I'm not actually going to be putting this engine back together, so I know the lad who's doing it. So once he's ready to rebuild, we'll check it turns okay. Should be fine. I haven't got the other side complete bearing to assemble the crankcase, unfortunately, but I'm happy with that. We're say from our setup, we're in line with the drive side bearing track following through to the timing side bush, and so we're in line that way. We're concentric with the bush that went in. The bush went in nicely, and that's machined nicely, and we're within tolerance for the clearance. So yeah, another one done. See you on the next episode. See what we can find to do then. So bye for now. Right, I couldn't not try it together, so I've made a quick spacer bush there just to fit on the crank and inside that bearing race. Try it together. Right, quick and rough way of doing it. So I've made a spacer bush. There's no play in that bush, but there's not any end float either. But that's turning. It's a little bit stiff because it's just running on a nylon bearing. But there we go. So we're in line. I'm happy once it's got the bearing on it. It'll be fine. I'll bring you around that side. See that? Yeah. And you can just about see the oil sort of pulsing out of the clearance when you rock it up and down. So yeah, I'm happy with that one. On to the next job.